Desk of Ladyada.
Hey everybody, and welcome to Desk of Ladyada. It's me, Ladyada, at my desk. We got a couple minutes worth of desk check-in. Phil, do you have any updates, like general purpose?
Yeah, can you point your mic to him?
Oh, sorry.
Now, this Wednesday...
How's that?
Good. At
Good.
3 p.m.
Okay.
we have Hack Chat. Let's go to hackaday.com, hackaday.io, and check that out. Noah and Pedro will be doing the show and tell, and then we got Ask an Engineer, 8 p.m. JP's product pick of the week is on Tuesday. Thursday, JP's workshop, and then on Friday, Scott's deep dive, and Wednesday morning...
I broke it.
Yeah, cool.
Sorry.
Yeah,
it's okay now.
No, it's...
Oh, no.
It's even worse than we started. We have a microphone issue here. And
Okay.
then what's happening right now, if you all hear water in the background, it's because there's a giant leak above our apartment. And this is like the second time or third time this has happened. But this time we don't have to get two of every animal and prepare an ark because we let the building know because we just happened to be here last time we woke up and there was pieces of apartment falling on Ladyada. So let's kick off the show.
I fixed it.
Yeah, you did good.
Okay, great.
All you have to do is watch out for the leaks and more. But speaking of leaks, maybe we'll have a product leak. We'll
Okay,
see.
let's go to the overhead. I got some fun products.
Yeah.
So one
Not
is
boring.
I had the Cutie Pie, the backpack type things that I developed a while ago. So I've been testing the lipo backpacks. I got a lipo battery, and here I've got the. I've actually changed the design. So you can see here this little red wire. I added a resistor divider to pin A2 so you can monitor the output from the battery or the input to the battery. Not the battery itself, but like the voltage after the diode. Because that means that you can detect when you're on USB power or when you're on lipo power. It's not perfect, but it's better because it's like there's a diode drop and it depends on how much current is being drawn. Then you can do some rough estimation of whether the Cutie Pie is running on the lipo as it is right now, or if it's running on the battery. Because if the voltage is above like 4.2, that means it's not being charged. So that's cute. And then you've got the the on-off switch, so I can turn it off and turn it back on. So that's kind of fun. So it's a cute little add-on to Cutie Pie. So I'm ordering those boards. I also got this, which I'm not going to sell. I don't think it's kind of finicky. But this is a iSpy adapter. So it takes the iSpy FPC connector out. And I actually thought this would be useful for me because I have a new display I'm testing, and I put an iSpy connector, and it gives you power and ground and all the pins for the display and the SD card, so that when I plug this in, hold on, with this cable, I can do very quick tests of a display. And so I still test it with wiring up each pin on a Metro Mini, but just for quick, did I get the basics going? Or if I want to test code on a display and I don't want to wire up the display, it's a little bit like Stemma QT, but for more complicated devices like SPI displays and stuff. So let's see if I can get it to focus in. I think it doesn't like how bright it is. There you go. So this is just doing a little demo where it displays an image, a bitmap off of the SD onto the TFT, and then it inverts the display back and forth, so I know the communication is working. So those are two boards that I got, and then I also have the 5x5 NeoPixel, shield thing, and I didn't put that together yet. But actually, while I was working on this, I ended up doing an INA 228 design that I did a long time ago. I finally got to. I was I really needed something to monitor the battery going back and forth. It's just an INA 209 is perfect, and then I looked all around here. It was 11 o'clock at night. I didn't have one. And so I was good incentive to put together the INA 228 prototype, and I got that up and going. It's a very nice chip. Unfortunately, you can't get it. So when the INA 228 is around, it's a 20-bit ADC power monitoring, and it does coulomb counting, and it does current and wattage calculation. It's actually pretty sweet. So I did that. I'm also trying to crank through a bunch of designs. Ironically, because it's Chinese New Year, things are a little quieter for me, which means that I can like kind of sit down and just like get through a bunch of designs where I've like made the prototype, but I actually have to finish it, right? Like it's not enough to design the PCB and order 5 prototypes. I have to like finish the design, test it, make sure I didn't make any mistakes, write any code, panelize the PCB, order it, you know, all that stuff. And it doesn't take a long time, but it's like, it's not as shiny and fun. So one thing I did also was a couple revisions. And one of these revisions is the DRV8. You can sort of see that this is buzzing here. It's a vibrational motor driver that uses I2C, which is quite nice. You know, it's great if you just want to like really quickly add some like effects to a buzzer. The DRV2605 does like double tap and like ramping for you, and it actually makes the buzzing feel kind of like more fun than just like on and off. Like it can do kind of effects, and it has I think like 100 different effects built in. So this is going to be Stemma QT-ified. Which is wonderful. Trying to get through all of the designs from the last like 10 plus years and get them into Stemma QT format. And, you know, I have to wait till I'm out. And then for a couple designs, I'm going to keep the old one because it's the shape is so, you know, it's so useful for people. Like they really want to design that break out into a PCB and they don't want it to change. And so, you know, I revised the ADS1x15, which is a very, very popular analog digital converter over I2C, and I made it Stemma QT format. But I actually think I'm going to carry both styles because just so many people have designed in the old version. So that's that. And then, yeah, this TFT also. This is a nice like 1.9 inch TFT. It's very long. And it's got this FPC connector, but it's quite nice IPS display. So a lot of like new stuff is coming out, and then we got a shipment of SAMD21s, which I ordered like almost a year ago, and these are the E18s, which I use for the Gemma, the Trinket M0, and all the trinkeys. And since you know, I can now make trinkeys again. Like basically, like I was coming out with a bunch of trinkeys, and then I had to stop because I couldn't get chips anymore, and instead of designing and not getting chips, I was like, well, I'll just do something else and I'll get back to it later. So one of the ones that I started to design but didn't finish was the VFD trinky. So this is a IN 3A, I think. Yeah, so you can see even. Sorry, IV3A. You can see the Russian text on the back. These were made in the 80s. It's kind of cool, like Russian retro technology. They're not as beautiful, kind of as Nixie tubes. Nixie tubes have this really nice orange glow. VFDs have a blue glow. But here's the nice thing about VFDs: you can get them. They're less expensive, and you don't need like 200 volts. You only need like 20 to 30 volts to drive them. They give you a nice blue glow. And so, you know, I figured out the pinout for these. I don't have my 30 volt power supply here on my desk, so check out the video that Phil posted on the YouTube where I show off the VFD display being
I'm
lit.
posting it tomorrow.
Sorry, check that tomorrow.
Yeah.
So
I did a clue of what it is on our social media channels, and it's not the thing that they dropped into Neo or at the time Mr. Anderson to bug them, but it looks pretty close though. Video comes out tomorrow.
Yeah. So check that out. Just Google for what VFD tubes. We used to stock a display called the Ice Tube, but then I couldn't get the tubes for a reasonable price. Like when I first came out with a design, I could get 1,000 tubes for like $2 a piece, and it was great for a kit. And then the price went up to $30 a piece. Yeah. Or they were not that expensive. It was like $5 a piece, but there just weren't thousands of it anymore. So we ended up stopping making the kit. But this little tube is cute and small. It's only a single digit. So I thought I would design a trinky. So let's...
Just on a side note, there was a mean guy that would send us nasty emails and stuff and say, you're using up all the tubes. You shouldn't use the tubes. My opinion about this is, what are you saving them for?
Yeah.
What are you waiting for? He was worried that these tubes would be, put to a good use.
They were being used.
Yeah, no, he was worried they would actually be used. And so I didn't really like that. But I'm glad that we might have another thing for people to check out. It's cool technology, and this is a nod to the past so we can build cool things in the future.
Yes, and we're not going to make, thousands of these trinkeys, probably.
They're not forever trinkeys.
Yes, they're limited edition, not forever trinkeys.
Yeah.
So let's go to the computer. I can show the
I don't
design.
think we'll say not forever trinkeys. We're going to come up with an acronym that makes sense. Yeah, like something that's kind of catchy that people will like. I don't know. All right.
Well, we're going to call it the ice tube trinky.
Yeah.
So this is the standard USB connection. You got the SAMD21E. I like it because you'd only need like one component to get this running, like two capacitors and a button. And then here you can see the circular design of the VFD. So they actually use the EagleCAD Make Circular because I've never used it before, and I was like, well, they will actually place pads in a circular pattern. So it's like, this is my chance, and yeah, it worked fine.
Huh. What did you do before?
Just like math, a lot of sine and cosine.
You just did math?
Just the math. Right. So the tube kind of comes out here, and you solder it from the bottom. And then I've got transistor drivers. So you see here, there's like 1, 2, 3, 4 dual NPN transistors, and then pull-up resistors. And the reason you can do this instead of actually driving 20 volts in, you use a pull-up and then you pull down to disable it, is the 20 to 30 volts is a signal. It's a biasing voltage. You don't need, it's not that powering current, that's the heater. Like the heater is what's drawing 20, 30 plus milliamps. The signal to the 20 to 30 volts to signal the each segment to be on is like maybe a milliamp or so. It's very, very little. And so you can use a pull-up resistor. I'll probably need to use like 1K pull-ups, but it's powered to USB, and look, I had to make it fit, and this was the only way to make the design a reasonable size. So it's kind of like a key shaped, right? Some sides are like a key that's in your keychain. It does have a lot of circuitry because you need a boost converter, and I also have a transistor to turn on and off the filament. But what I did is I connected the enable pin of the boost converter. First off, I pulled it down low by default. I connected this to my controller pin. So, when it comes up, the boost converter's off, and so those filaments aren't going to be on. So I don't have to worry about that. And then, segments won't be on. And then when I'm ready, I'll set all the NPNs to be low, or turn them on so that the filament voltage is, the segment voltage is off. Sorry. Yes, it's low, it's off. And then I'll turn on the boost converter, and that way, I don't end up turning on all the filament segments all at once. And that should be fine, except I keep saying filaments when I mean segments. And then this is each, NPN. I've got 8 NPNs, 1 for each segment, and this is what what it looks like. You've got 8 segments, A, B, C, D, E, F, G, and then dots. Ground, the the grid voltage, which is again that 20 volts. That's what activates the vacuum fluorescence. And then the cathode, which is the heater. And for that, you need about, I think it's like 30 or 40 milliamps at 1 volt. If you can generate a volt, great. But if you don't want to, you just treat it like an LED basically. And you back calculate based on a 3 volt power supply what your choke resistor is, and that's fine. And I put it on a PNP to be able to disable it also, to not have it on at first, and then I can turn it on when I'm ready to light up. So I think this should work out. I mean, I did work with VFTs on the ice tube clock, but it's been like a decade, so I'm gonna have to remember all the details of it. But I think it should be okay. I got 10 of these little tubes on hand, and I'll send out this PCB, and you'll be able to do CircuitPython VFD. It'll be kind of cute, very fun.
Okay.
All right.
Do you want to do the great search?
Yes. Is there any questions before we?
Ever thought of some input feathers, optical isolating feather, voltage divider feather, maybe a 74 HCT 4050 feather with up to 15 volt inputs or something for vehicles? Love me some feather.
Yeah, I haven't thought of that. I mean, I think that's a good thing. That, you know, community member who's expert. So I don't have a vehicle, so it's like if I made it, I wouldn't necessarily know how best to make it work. I did design a can feather wing, and then, you know, of course, the chip that I was using, the MCP 26525, it's completely disappeared off the face of the earth. Like, I was like about to buy 1,000, and they're gone, and they've been gone, and it's one of the ones where, you know, it's just not, Microchip's not making them right now. So it's kind of a bummer because, like, all the code was ready and everything was ready. A few chips were like that. Like, designs were pretty much ready to go, and then I had to sort of pivot. So the thing about VFDs is, they're not making them anymore, but they've never been making them anymore, and so I don't have to worry about getting them in a year because they exist now or they'll exist never. That's it. So.
All right. What are the odds someone will take advantage of the VFDs running out and figure out producing more? I think
Zero.
I think Russia's kind of busy right now invading Ukraine.
Yeah, nobody's going to make VFDs.
Yeah.
I mean, not these tubes. They do make VFD displays, like the Noritake displays. Yeah. They're expensive. They're hot. They look great. We used to stock them, but people weren't willing to pay $100 for a VFD, and they've been slowly replaced with TFTs. So there are VFD makers, not for the tubes. They're for plates. You can get them, but they're slowly but surely kind of ending. You can still see them on cash registers. I mean, I don't think they're making a ton of them with them anymore because, again, they're much more expensive than LEDs or TFTs. I don't think you need something that bright, but that's where they're used.
What'll be cool is you'll see us on Desk of Ladyada and on our shows, and you'll be able to get one of these while supplies last, literally.
Not forever.
Trinky. Not forever Trinky series. You know, sometimes people take the first letter of each thing, and they do something, but I don't know. It's like just a crazy idea.
Okay.
Let's do the great search.
Let's do the great search.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single week, Ladyada uses the power of engineering to show you how to find things on digikey.com. It's a good thing to know how to do because things are harder to find now.
In fact, one of the things that I was going to show one of my favorite parts, and then it's actually not available, so I'm going to show how to find an alternative to this part. So let's go to the computer and I'll show what I am working on and what part I'm looking for. So I'm going to be driving a VFD display. VFD displays need 20 to 30 volts to bias the grid and each segment. And so I need 20 volts, and my thing is running off of 5 volts. And here's the good news. The 20 to 30 volts, you don't need a lot of current. You only need about 10 milliamps or so, which is not a lot. It's just basically to kind of bias it. The current draw isn't high. It's just the voltage is high. And so if it was like 6 or 12 volts, 6 to 10 volts, I might use a switch cap converter because I'm powering this thing off of 5. And so I have 5, I could double that to 10, but like 10's not high enough. And I don't want to get 2 switch cap converters. Switch cap converters are very inexpensive. They don't have a buzzing, they don't have an inductor, they don't have a diode, so they're quite nice in general. And I'll use them when I need like 5, 6, 7 volts from 3 or 5, but in this case, again, I need 20. So what I need is a little boost converter. So my favorite is, one I use a lot for OLEDs, also need a biasing voltage. Again, not for... they don't use a lot of current at that biasing voltage, but you do need like 5 to 10 milliamps at 12 to 18 volts depending on the style and color. So I've kind of come up with a boost converter that I use a lot for all of these devices that need a little bit of a high voltage, and it's based off of the Fan 5331. The nice thing about the Fan 5331 is it's a kind of a nice generic boost converter. You do need a diode. It's not synchronous, and you do need an inductor, and you need a little resistor divider on the output to set the voltage. But it's a SOT 235. These are very easy to place. They don't take up a lot of space. They're very easy to use. I've never had an issue. I've never really damaged one. They're not high current boost converters. They're very dependable, simple ones, and there's an internal MOSFET that's good for 1 amp switching, which you don't need to use that. And I think the frequency is almost a megahertz. So the high frequency ultra low cost, I think like 20, 30 cents, and easy use. So that's the good news. The bad news is, and this is how I organize my projects. The bad news is the fan 331, at least when I checked earlier today, was not in stock. And it's not in stock. It is a great little chip. Again, it's like, 50 cents in quantity. Very easy to use, but it's not available. So let's find an alternative. Yeah, that's what we do. We're gonna be doing this for the next year or so. Like lots of alternative findings.
Come to my new site, alt.parts.
It's altparts.com. So the thing that's important to us is we want it to be an active DC-DC boost converter with an internal switch and one output. However, the voltage supply can vary. The voltage output, 20 volts or so. The frequency, this is 1.65. We don't need that. And I really do want it to be a SOT 23.5. So let's see what comes up. And this is not the one I wanted. Hold on. Oh, right. So here's the thing about the fan 331. I forgot to mention. So this is actually categorized as an LED driver. So boost converters, you'll find them in both locations on DigiKey. Some of them show up in LED drivers and some of them show up in DC-DC boost. So just be aware. In this particular case, there are a couple of alternatives. This LM series, which are probably fine, and some microchip ones. But I wanted one that was kind of around the same price and also, in stock. And I only think there's these are in stock and they're not too expensive. They're like $1, $1.50. But I wanted one that was cheaper. So I'm actually going to I want to search for DC-DC boost, and that'll take me to a different category. Switching regulators. Not controllers. I want the regulators because the regulators will have internal switches and it'll regulate the voltage for you, whereas the controller is just like the PWM controller. Okay, so I want active, and I want one output. I want it to be surface mount. So select that. Bigger. And I want it to be that 5 SOT. So I'm going to pick 5 T-SOT and then SOT 23.5. And I think this is always confusing because there's lots of different names. T-SOT 23.5. And then, I think that's good. I remember the part I found. I have to just remember what it was. And then I want it to be a positive step up with adjustable output because I want to, set it to 20 volts, and that's usually not a default output. And then when I search down here, and then I want to make sure that the voltage, sorry, I forgot to mention, I want the voltage output to be at least 20 volts because I need to have that 20 volts bias. So I'm going to skip all the ones that are 5, 6 volts output. And then everything else here looks okay. Right, so this actually is what ended up coming up. So I've never used this part before, but it's very promising. So the AP 3012 KTR, which has 120,000 in stock, which is kind of sweet. And the pricing is, 15, 20 cents. So this is a adjustable boost. You can give it 2.6 volts to 16 volts in, and you can set the output to be 1.25 to 29 volts. There's an internal 500 milliamp switch. Don't forget the switch current doesn't tell you the output. You can rough it as the output voltage divided by the input voltage divided by the switch tells you the current output. So if my input is 3 volts and my output is 30 volts, then the switch, that's a 10 times multiply, 3 to 30. The 500 milliamp switch, I have to divide that by 10, by whatever the amount I'm boosting, because it's the switch is from the input, not the output side. So this will give me 50 milliamps output, which is still plenty, right? Even in worst case, usage. Although honestly, I'm going to be 5 to 20 volts probably, so I can get like basically 50 to 100 milliamps out of this. It's a SOT 23, and then this is the pinout for the fan 331. So switch, ground, feedback, shutdown, VN, and then this is the output for the K package of the AP3012, also switch, ground, feedback, shutdown, VN. So this will be useful. I think there's another one of these. One second. There is the E and the G. Well, that's probably a temperature thing. I don't know. Let's use the compare. Can I compare? I've never used the compare. Okay. So this one's a little more expensive. Step up. These look very similar. This is E versus G. It's probably like a percentage rating or something, like 1 or 2% accuracy, and maybe like the behavior when it latches up. So I'll look at what the difference between the E type and the G type is. But it's cheaper than the Fan 5331. So I'm actually going to pick up some of these and I might use them in some of my designs because like if I can save 30 cents in this chip, like there's 120,000 in stock, which means it's probably going to like, sometimes it's like the more there's in stock, the more I trust it. So I think that this is a good pick. So I'm going to pick up some of these AP 3012 from Diodes Inc. I do like the AP2112. It's my favorite regulator, so it's going to be my new favorite boost converter.
Should do a segment in the future. Favorite
My
regulator.
favorite. No, the AP2112 is like pretty sweet.
All right. And is that the great search?
That's the great search.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay, I'm going to do a couple comments that came in, and then we're going to do a couple questions. Some nice kudos on the great search segment. Really up my game when it comes to finding replacement and original parts for a lot of work projects. I feel that you must be great at the game Connect 4. It's true. Awesome searching. I find I learned a ton from these segments just from watching which parameters Ladyada decides are important and not important. And it's cool to watch her narrow it down to the best choice. Okay, so the question, this one came into Discord.
Yeah.
Question for Ladyada. This person's on mobile, so it'll be brief. Is there a reason there isn't a way to turn on a pattern of LEDs at full brightness off in the AW9523 library? I'm planning on writing one, and I'm wondering if there is a structural reason to do that or something dangerous to the chip I should be worried about.
No, I think the way I wrote the library was just, simplicity, which is, you turn on each LED in a row. I don't think I set up so you can write all of them at once, but, you can adapt the library if necessary. There might be an output setter where you can set them. I mean, check the header. Like sometimes I have, the ability to set like the entire register at once. It's just a little more dangerous, right? Because like you're writing all of the pins. And most people, I like to make it so it's like you're only doing one thing at a time.
Okay. And then next up, this isn't a question, it's kind of fun. This is why we do what we do, one of the reasons. This is from Jem. Fun story today. Went to a friend's house to help her shovel out from the snowstorm yesterday. After we're done, she pulled out an old floppy disk that she found in some 12-year-old files, and she asked, is there anything I could do with it? The answer is, yeah, you'll be able to do a lot of cool stuff with floppies, and we'll have some projects more. Continue to stay tuned.
Hold tight.
Yeah.
Keep that safe.
We have a lot of things that'll help everyone rediscover all sorts of things
Don't put it on
in their files.
Don't put it on something magnetic. Just hold
Yeah.
on to it.
All right. And then do you have a matching inductor you prefer?
Now the inductor really is, whatever you need. So I have a different inductor. I do have a simple 10 microfarad inductor, microhenry inductor that I use for a lot of designs. It's just like a simple surface mount one. But the inductors really do have to be tuned to whatever it is that you're using. So check the data sheet for the specs. I think one of the first great searches we did was how to spec an inductor.
Yeah. Do you simulate your circuits first in like LT Spice?
No, but I'm also not doing analog stuff.
Okay. Do you use PWM for LED lighting?
Yes, you will. That's a good way to do it. Or constant current is preferable. Pick whichever one you can.
Pick your poison. Okay. That
All right.
looks like all the questions. Thank you, everybody.
Thanks, everybody.
So much. We'll keep you entertained throughout the week. Hopefully inspire you to share your projects, your work, your code with one another. Help uplift one another and more. We do this every single week. We'll see everybody next week. We're going to hopefully not get too flooded here
I know, I'm looking
in
at
our
the-
apartment. Yeah.
The bucket is.
Yeah.
I took my trash can. I just put
Yeah,
under
from the desk of Ladyada will probably be buckets to collect some of the water.
Yeah.
But we'll see everybody during the week, and thank you so much for joining us, and thank you for all your support. Keeping us going, visit adafruit.com and pick up something that pays the bills for these skills. All right,
All right,
everybody.
thanks,
that's it.
everybody.
Bye-bye.